In this video, I'll be showing you how to answer all of the weather data related questions from the IGCSE Geography Cambridge papers. So to recap the purpose of this video, is to show you how to answer questions that require you to state weather instruments, take readings, calculate data and explain how and why we use them. The examples I'm going to show you in this video are predominantly based from paper 1 and paper 2 exams, but these questions do appear, these styles of questions do appear in paper 4. Really, it's to offer you hints and tips on how to approach these questions. And please do use the chapters to skip to the various tools in case you know how to do one of the tools, but you're not quite sure how to use another tool. And please follow and complete using past papers as we go. So the styles of questions that you could be asked. You might be given an image, a series of diagrams, and you have to identify the instrument from them. You might be required to state the units or the data it collects. You might be given the loads of resources and you have to work out some values. You might be asked to outline how you use it to collect data. You might be able to explain certain design features and then describe some data. Now, throughout this video, I won't be, not every instrument, I could find examples that tick all of those boxes, but certainly I will cover a broad range. So these are the instruments that you're required to know. A wind vane, an anemometer, a rain gauge, a max-min thermometer, a wet and dry bulb, sunshine recorder, barometer, cloud cover, and Stevenson. And just again, chapters at the bottom, please click through if you know about one, but you're not quite sure on another. So the wind vane and anemometer. So the wind vane points towards the direction the wind is blowing from. Most important. It uses points of a compass. The direction the wind is blowing from is really important. So for example, in North Europe, wind from the north is generally colder. With the anemometer, the faster it spins, obviously, the stronger the winds, and you must check the units. It could be in meters per second, kilometers per second, or knots. So do check. So, types of questions that could be asked. Here's one. Identify the 3 weather instruments shown in figure 7. So as long as you know what the weather instruments are, fairly straightforward. A, wind vane, B, an anemometer, and C, a max and min thermometer. Now, using instrument A, state the direction from which the wind was blowing. Now remember, the weather vane, wind vane, points in the direction that the wind was blowing from. So in this question, it's blowing from the north. Double check the answers. Yep, all correct. All correct. And here's a similar question taken from paper 1, not paper 2 like the previous question. First part, identify the weather instrument, wind vane. Second question, explain how the readings are taken from this weather instrument. Like I said, the wind vane points in the direction that the wind is blowing from. In this case, it appears that the wind is blowing from the southwest. Just check the mark scheme. Wind vane, brilliant. All correct. Moving on. Describe and explain the ideal location of the weather instrument shown in figure 4.1. So remember, just a little tip, the wind vane and anemometer pretty much require the same sort of location. In this case, you're going to have a tall tower, pretty much about at least 10 meters, or on the highest point in a given area. It needs to be in a relatively open space, so not disrupted by other buildings, trees, or obstacles. So if I was going to write an answer, I would say something like this. Placed on the top of a large tower or on the tallest building in an area. As well, it would be preferably placed in an open space or away from other buildings so they cannot influence or block the winds. Let's check our marks against the mark scheme. On a rooftop, yep, 1 mark. It's higher than the surrounding buildings, yep, implied, and so there is nothing to block the winds. Yep, all 3 marks. Let's move on. Like I said, some of these questions could also appear in paper 4, the geographical investigation. Here, you're required to identify the wind instruments, an anemometer. And then you're required to explain how this instrument measures wind speed. Well, use the image as some clues. You can see there are cups that obviously are going to spin, and there's some sort of display at the bottom. Check the units. And with that information, you can write quite a quick but detailed answer. So for example, the cup spins, yep, and the reader at the bottom counts the number of revolutions. This is then converted and is shown as kilometers per hour. So if I check my answer against the mark scheme, yep, the first answer is correct. Yep, cup spin, brilliant. A meter counts number of revolutions, brilliant, and displays and shows the units which are kilometers per hour. Fantastic, 3 marks. Now, sometimes you might be required to interpret or draw data. So let's look at a question. Here, name the type of graph shown in figure 5.1. This is taken from a geographical skills question. A windrose, for those of you who don't know. Now, use figure 5.1 to identify how many days in the month the wind was blowing from. Well, if you look at the units, you can see that it goes up in 6 segments, 1 segment for each day. And so I'm going to count the number of segments that haven't been shaded. So look at the north. Sorry, I'm looking at the south. Okay, so 4 of those days have been shaded in. Total is 6. So the answer is going to be 4 days. Using figure 5.1, identify the prevailing wind direction in the month. Well, the prevailing wind is the predominant wind or main wind in an area. So if I look at this diagram, I'm going to be looking at the area that's predominantly shaded in, or the direction that has been shaded in the most. So in this case, it's west-southwest. Check my answers. Yeah, let's move on. So another weather instrument that you might be required to interpret is a maximum and minimum thermometer. Now this shows the present temperature as well as the highest and lowest temperature within a given time scale, usually a day. The difference between the maximum and minimum gives you the range, and it's generally found within a Stevenson screen. If you don't know what a Stevenson screen is, click on the chapters at the bottom to move forwards. These type of questions that involve a maximum and minimum thermometer often require you to identify what the temperature, present temperature was, and the maximum and minimum. So how do you do that? First of all, use a ruler. Now where the liquid currently sits, the mercury inside the thermometer, that tells you the present temperature. So read off both sides, 7 degrees. Now what you can see to work out the maximum and minimum is inside the tubes there are these little markers, and they're essentially pushed up by the mercury and then rest once the maximum's been calculated and the minimum's been calculated. So in this context, to look at the maximum, in this case, you look at the side that's got the highest Celsius, so on the right-hand side, you look at where the bottom of that marker, because obviously it's been pushed up. So that's going to read as 15 degrees. And then for the minimum temperature, again, you look at the bottom of the marker where that rests. So in this context, 10 degrees. Now, a question they might ask you is to calculate the range for that day. Yep, the marks you can see, 100% correct. So if you were to calculate the range, obviously you would take the maximum or the minimum away from the maximum. So in this context, 15 minus 10, which is 25 degrees Celsius. And you can see that right here. So again, taken from another paper 2 question, using the information in table 1 to complete the table below. The daily temperature range on Monday. So maximum minus minimum gives you 6 degrees. The mean temperature on Tuesday. Well, you've only got 2 temperatures, so to work out the mean, you need to work out the average. So you're going to add 22 to 14 and then divide by 2, which gives you 18 degrees. Now, this one's a bit annoying. Suggest which day had the least clouds. For me, I would be looking at the highest temperature, which suggests the most evaporation and perhaps burning off any excess water vapour. So, Wednesday. Yep, it's smart scheme, all correct. So, another weather instrument is a wet and dry bulb thermometer, or you might see this as written as a hygrometer. It works, it's got the same liquid as a regular thermometer, but there's a little container of water inside. And what does this do? It measures the humidity or the moisture content of the air. It's often given as a percentage, and the water is required to keep that thermometer cool. And we'll show you how you use these two readings in a minute. And again, you will find this in the Stevenson screen. So again, another common question where you are asked to do a little bit of work, calculation, and then work out the relative humidity. So, common diagram, you've got the mercury there, and you've got the water in that little container. So state the readings of the wet and dry bulb. So which one's the wet bulb? Obviously the one that's got the container. So in this context, we look at where it's rested, and that is 10 degrees. And for the dry bulb, where it's rested, 18 degrees. Now, where it says calculate the depression of the wet bulb, what that means is the difference between the wet bulb and the dry bulb. So in this case, 8 degrees. Using your answers to BI and I2, state the relative humidity. Well, here we need to move to our table. You can see on the left-hand side it says dry bulb reading. So we go down to 18 degrees. Across, we've got the wet bulb depression, in this case 8 degrees. And where those two lines cross, that is our relative humidity, which is 33%. Check the mark scheme. Brilliant. Make sure to write that percent. Like I said at the start, sometimes you're required to describe changes in the data that's being collected. So here's one about relative humidity and temperature over the past 24 hours. Now, in these type of questions, it can be quite frustrating, although they're straightforward. If you have to describe and you know that you can use statistics, it always gets you a mark. It's always frustrating when this is written. Do not use statistics in your answer. So how do you go about getting the full marks? In this case, there's a whole 5 marks on offer. Well, you've got 2 lines. You need to break it up into the various parts. So for example, temperature and relative humidity. Half the answer needs to be on temperature, the other half needs to be on relative humidity, and then perhaps you want to conclude with how do the 2 relate to each other. So if we take temperature, what I would be tempted to do is divide up the graph into various sections. So in this case, periods when it declines and periods when it increases. And then once you've got that, it's much easier to describe. Although you can't use data, you can still use the x-axis, and in this case is time. So temperature starts low at midnight and continues to decline until 7 o'clock in the morning, before rising again to 3 o'clock in the afternoon, before it starts to decline again. Then if we do the same for relative humidity, have the various sections of where it's stable, declines or increases, then we can say it rises from 6 o'clock to 7 o'clock before falling again. And then overall, as temperature increases, so does the relative, overall, as the temperature increases, the relative humidity decreases. And if we look at the mark scheme, again, we've got those periods in place. We've used the timings. We've said when it's high and when it's low, and we've compared the 2. So another method that you're required to know about is a rain gauge, and we use this to measure and collect precipitation. So remember, precipitation is anything to do with snow, hail, and rain. So how does it do that? Well, as you can see here, there's a funnel that collects the water into a graduated cylinder, which is about 2 centimeters in diameter. And you can see that along the cylinder, there is the units of measurements. And you can also see that cylinder that's got the units and measurements in is placed within a larger container. And that's really important to know. Now that container can vary in height. Generally speaking, it could be up to 20 centimeters in diameter and 50 centimeters tall. It very much depends on what you're collecting. So the depth of the rain in millimeters can either be given, in millimeters or centimeters, but always double check the units on the side of the cylinder. It must be kept on a flat surface, obviously. And the top of the gauge needs to be around 30 centimeters above the ground to ensure that rain splash from the ground up does not affect the results. So these are the various factors of how you go about locating it. You can also see there in the image that it needs to be in an open space, and so it won't be affected by any drips from leaves or anything like that. So this is a question from a skills paper, paper 2. Describe the ground surface where the rain gauge is located. So obviously flat lands. Choose 3 features of the rain gauge shown on figure 5 and explain how each one helps to measure the rainfall accurately. Well, you can see here that the rainfall gauge has actually been placed, it's not on a post, it's actually been put into the grounds. And that's quite useful. So there's various points that you can mention are, the funnel helps to concentrate the water into the container. The top of the main container is about 30 centimeters above the ground to avoid rain splashing back in. And part of it is buried in the ground to prevent evaporation, so it keeps the water nice and cool. Again, if you look at the mark scheme, it's placed on flat grounds, and you can see all the various points about the design features. And again, with those, you might want to incorporate the mark scheme into your notes. This paper I've taken from a geographical investigation paper, paper 4, which you don't have any choice in. You would have to answer this question if you decided to take it. So it starts off nice and easy. You have to match up the measuring instrument with the weather feature measured. So atmospheric pressure, barometer, temperature, thermometer, wind direction, wind vane. Now this is when it's quite interesting. In the box below, draw and label a traditional rain gauge. I'm not going to do that now, but what I am going to show you is what the mark scheme says, the various things that you need to contain. If you go back to the previous questions I covered with rain gauge, you can see the type of diagram that you need to draw. My only advice to you is actually put on the scale onto the cylinder that wasn't present on some of the diagrams featured in previous papers. And again, you can see how you need to describe the location of where this data has been collected. So describe and explain a good position to put a rain gauge to make sure that the data collected will be accurate. So place an open ground away from trees to avoid drip from leaves. Fixed in the ground that is flat, so the rain gauge is less likely to blow over. Again, I've stated that and I've stated why that will lead to more accurate readings. Here's some more ideas in the mark scheme. Again, incorporate those into your notes. Now, obviously, a key driver of weather and our global climate is sunlight. And this is this is the instrument that we use to collect sunshine data. Basically, what it tells us is how long the sun has been shining for, the number of sunshine hours in a day. The glass sphere concentrates the sun rays onto one point. So whenever there's been more sunshine at that particular time, it will concentrate the rays and burn essentially a mark onto the record timesheet, which you can see behind the glass orb in the picture. At the end of the day, the number of hours and minutes of sunlight can be viewed from the record time sheet. And it's placed in a location that experiences the sun all day. You're not going to put it into a point where, for example, if the sun passes a building, shade covers that sunshine recorder, it's going to be kept in an open space. And the card plate must be behind the glass orb. The glass orb must be facing the sunlight at all times. This question has been taken from paper 1. And here you're given the insert. You can see the insert on the right hand side, and you have to tell me the name of that weather instrument. So you would put something like a Campbell stroke sunshine recorder. Now, generally speaking, the mark scheme is quite generous, and you can just put sunshine recorder. How it's used, like I said from the previous point, the recorder is kept in an open space pointing towards the sun. It is left for 24 hours, so the sun has time to burn a line onto the time card. Look at the mark scheme. Yeah, ticking all the boxes there. Again, include the language into your revision note. Like I said, the sun obviously drives our weather and climate, but another very, very good indicator of what the type of weather is going to be is pressure. Here in the picture you can see a barometer, a traditional barometer on the left-hand side and a digital version on the right-hand side. And depending on that value, we can have an indicator of the types of weather that might arrive in our location. So, what is pressure? Well, really, the barometer measures the amount of pressure the atmosphere exerts on the Earth's surface. And it is a very good indicator of what weather we could expect. High pressure, or we refer to as an anticyclone, tends to bring clear skies and light winds, whereas low pressure, depression, tends to bring wet and windy weather. It's measured in millibars, and relative normal pressure is around 1,000 millibars. Anything above 1,000 is considered to be high pressure. Anything below that 1,000 line is considered to be low pressure. Above, high pressure, below, low pressure. Clear skies and light winds, wet and windy weather. Now we can plot these points on a map using isobars, and isobars are a bit like contour lines. They join lines, whereas contour lines join points of equal height, isobars join points of equal pressure. Here is an example of isobars on the right hand side. You can see if I follow that line around, the pressure would be 1004, 1008, 1012. So, nice skills question. What is the air pressure in Townsville shown in figure 5.1? Well, find Townsville, follow the line, because it's joined to find out whatever that value is. Remember, isobars join points of equal pressure, so 1004. The units of pressure are abbreviated as MB. What does MB stand for? Millibars. What instruments used to record air pressure? Barometer. So, again, what I wanted to show you is that it's very important you know the units, if they've been abbreviated, what does that stand for, and the instruments. These, if you had this paper, it's a very straightforward 3 marks. Now this question is a bit tricky, and you can also use this skill to maybe answer an earthquake question, or maybe to do a pedestrian count if you're doing geographical investigations. It's completely isobar, or isolines. Again, check the mark scheme, yep, all correct. So, how do you go about drawing isobars? Well, you need a pencil and rubber, first of all. You need to find points that are lower than 1016, because we have to draw the line 1016, and higher as well. So in the first example, you can see we've got 1014 and 1018. And I want you to imagine a straight line between those 2 points. So here I've got 1014, I've drawn a straight line between 1018, and a straight line between 1014 and 1017. I want you to draw on that line. Imagine where would 1016 appear. So in the case of the first one, 1014 and 1018, 1016 is exactly halfway between the 2. So I'm going to put my little red X there. Again, you will need to draw this in pencil, but red will stand out better on my screen. And for 1016 here, it's not quite halfway, it's slightly closer to 1017, so I'm going to put my red point there. And I'm going to continue doing this, finding all the values that are between 1014, that are below 1016 and above 1016. Drawing all my points as we go along, and then as I go, I would connect the dots. And that's how you go about drawing isobars, isolines, pedestrian counts, whatever you've been asked to do. Yep, isobars drawn correctly between 1014 and 1017. Right, describe how the pressure varies across the areas shown in figure 5.1. Use statistics in your answer. Again, so we can use the data available. And so you must get that data, because if you don't, you won't get full marks. So you have a map and you have an arrow, a north arrow. Again, that's really useful information that you can use. So you must include compass directions. So here, use statistics in your answer. So, and show how it varies given the highest and lowest value of the data, and use the north arrow key to help you identify where those areas are. So we can say, for this point, the biggest change can be found over Western Australia, as the highest pressure can be found in the southwest with 1024 millibars, and the lower pressure can be found in the northwest part of Australia with 988 millibars. If I look at the mark scheme, yep, I've done direction, I've done location with using the compass, and I've included data. Fantastic. And I've stated where the biggest change or the biggest range can be found. And sometimes, again, you might be asked to complete a line graph. So here, plot the air pressure between these two times. So again, you must use a pencil and rubber. And before you start drawing, just spend a little bit of time working out the scale that has been used and copy how they've done the lines. So that you can see they've drawn the points with a red X, with an X, and they've connected those lines with a straight line, not a curve. So again, I've done this in red because it's easier for you to see, but you must do this in pencil. So the first point at 9 o'clock is 1008, and again at 11 o'clock it is 1009, and so I'm going to draw straight lines between those to get my 1 mark. Often in an exam question, people tend to miss this, so please do double check that you have answered all these questions, because again, it's a very simple mark to get. And yet, points of 1008 and 1009 are drawn correctly, both to get the full mark. So another part of weather data that we can collect is cloud cover. Clouds appear when there is too much water vapor for the air to hold. Just to recap that, some questions do actually ask you to describe how and explain how clouds are made. So it's important about what is a cloud. Water vapor condenses to form tiny water droplets, and these droplets are so small they stay suspended in the air. So we only start to see it when water starts to condense, and that's generally around a piece of an air particulate, maybe a piece of dust or sand or something like that. There are many different forms of clouds, and you need to be able to tell the height and layers in which these clouds are formed, the colour, a description of them, the type of weather that they can bring. So how do clouds form? Well, really clouds form, and I've taken these diagrams from BBC Bitesize because for me, I think they're brilliant. Clouds really form when warm, moist air is forced to rise, cool, and condense. Now, there are 3 ways that you particularly study that can be linked to deserts or tropical rainforests. So I'm just going to go over the main ones now. You have relief rainfall, convectional rainfall, and frontal rainfall. If you don't know what those are, please do go back over your notes or use this bite-sized link. They're very, very good indeed. There are many different types of clouds, but what you are expected to know really are the 4 main types of clouds. The first one is cirrus clouds. They are found very high in the atmosphere, tend to be between 6 to 10 kilometers, and they look like a horse's tail. They're made out of ice crystals, and they're very white and wispy. Another one are cumulonimbus clouds. These are the huge storm clouds that look like an anvil on top, and they cover all of the layers. Other types of clouds that you're expected to know are stratus. They are low level, so they're formed at the lowest level. They tend to be a grey blanket of cloud that bring rain and drizzle. And you've got cumulus clouds, they're sort of mid-layer clouds between 2 to 6 kilometers. And we can describe these as white, fluffy cotton wool, and they can bring rain showers. So these are the 4 main types of clouds. Please do make sure that you know what they are and you have their key characteristics written down. So how do you measure cloud cover? Well, it's an observed value that we collect. And really, this diagram sums it up really nicely. Hold up a piece of card that's been cut into 8 sections, and we look at how much cloud covers those 8 sections. And so we give it as a fraction, and we use the unit octaves. So, a question from paper 1. Here we've got an insert of 3 different types of clouds. First question, what units are used to measure the amount of cloud cover? Octaves, 1 mark. Here, complete the table below by inserting the types of clouds shown in each of these figures. This is a really nice question, and it gives you lots of help because it tells you the 3 that you need to know. And these, again, are the 3 broad types of clouds. Then there are lots of subsections. So let's look at figure 3.1. Okay, these are they look like cotton wool. They're white and fluffy, so they must be cumulus. 3.2, it's a blanket of cloud. It forms a layer. Strata, you might hear this term in stratovolcanoes, layers, so that must be a stratus clouds. And then the last one, nice, very high up, wispy, so cirrus clouds. Check the mark scheme. Again, all correct, 2 marks. Moving on, describe the main characteristics of the clouds shown in the photograph you have chosen. So you can choose any of these types, and really, I didn't want to go through an answer because I wanted to leave the mark scheme up on the screen. This is a brilliant mark scheme because it tells you all of the main characteristics of each cloud type, the main cloud type. So please pause this video and write these key characteristics down into your notes. The only thing you might want to mention is the height of which they are found. And the last one, explain how cloud type and amount can be recorded over a period of 2 weeks. Now the key bit in this is 2 weeks. You could mention that in your answer. So, how do we do it? Again, it's done by observation. So, something that you mentioned, you need to, first of all, like any investigation, decide the times during the day and place that the data should be collected from. At the set time, stand outside looking at the sky, hold up a card that's been cut into 8 equal parts. Decide how many sections have been filled up by the clouds. The units for this are octaves. And record this data in a table. Again, look at the mark scheme, you can see I've incorporated that into my notes. And again, this is something that you might want to do as you find past examples, is if you're unsure, look at the mark scheme and include those into your revision notes. And another key bit to mention about any investigation that you do when you're describing how you collect data is that you always repeat this method each day for a set period of time, in this case, 2 weeks. So the last method that we use to collect data is an instrument that puts together that we store lots of different measurement instruments. It's a Stevenson screen. Now these are a standardized shelter. Stevenson screens are very similar, and they are built and placed in the similar locations all around the world. They are white, they're kept 1.25 meters above the ground, and they have these side lues or open slats that allow air to flow in. It tends to contain wet and dry bulb for humidity and air temperature, but it can contain barometer, although this is mainly kept outside. Now, although Stevenson screen can be found by itself, outside around it you might find a rain gauge, an anemometer, and a wind vane. Now, again, they're kept on flat open ground to ensure full exposure to the elements and not to be influenced by buildings, trees, or anything else. And it tends to be on grass, so not to be affected by radiated heat. For example, if you're in a city, huge dark surfaces, when that radiates heat, that could influence the data. So, typical questions that can be linked to a Stevenson screen. Again, you might get given a range of weather instruments, and you have to tell me which could be kept inside a Stevenson screen. Well, A, C, and D must be kept outside, so it has to be B. And then again, just to recap, identify 2 weather instruments shown in figure 4.1 which measure the following weather data: atmospheric pressure, it's a barometer, and precipitation, a rain gauge. And then again, you might have to match up the weather instrument with their names in the table below. And again, very nice, straightforward questions. So 6 marks, as long as you knew it, really 6 very straightforward marks. Double check, yep, everything's correct. So here, using the information in figure 3, to complete the table, adding 1 reason for each feature of the Stevenson screen. Stevenson screen here, and you've got the various features on the left. So, painted white. This is to reflect the sun and so prevent heat absorption. The slats allow air to flow. The double roof provides insulation. It prevents the sun from entering, and to avoid ground heat from affecting the readings. Look at the mark scheme again. Brilliant, good language for you to incorporate into your notes about when you have to describe the features of a Stevenson screen. Although this is a skills question, I've also seen similar questions appear in paper 1 and paper 4. Now, the final types of questions that could be asked is requiring you to compare digital instruments versus traditional instruments. So I've taken this question from paper 1. The question is, explain the advantages of using digital weather recording instruments rather than traditional instruments. So what do we mean by that? Well, here is an example of a max and minimum thermometer. One on the bottom is a traditional instrument, and the one on the top is a digital instrument that displays the data using numbers. So why could that be an advantage? Well, think about it. Firstly, the readings can be exact, as they can be given to one or more decimal points. So instead of here trying to work out exactly what it is between the various points described on the left-hand side, this gives me the top picture gives me a clear indicator of the maximum or minimum temperature. And so it eliminates human error. Second reason, well, the device could be connected to a laptop or computer, which could automatically and continuously record, analyze, and present the data as it's coming in. And thirdly, once the device has been set up, you will not need to be able to continuously handle it in order to collect that information, which could lead to breakages. So again, looking at the mark scheme, we have ticked all of those boxes. So although you might not be, this might not something that be clear in your textbook or notes, questions do require you to look at comparing modern digital tools versus the traditional instruments. So please, again, have these reasons put into your notes. So just to summarize, I've used a range of paper 1, 2, and 4 questions to show you the types of questions that could be asked on weather data, weather instruments. Now, I couldn't find questions on all of the different aspects that you need to know, so please do make sure that you have covered all of them. If you're unsure what they are, go back to the introduction to work out what you need to know. But typically, you need to be able to tell me the units, what the instrument looks like, what they collect, how you collect the data, and you might be able to be required to describe graphs and explain where and how you locate and place these weather instruments. Now, do incorporate any mark scheme responses into your revision notes. It's really important. I find that very useful in helping me with the language that's required, and it helps you to remain concise and to the point. Because if the exam board have used it, then it must be correct. Do find past papers and practice, and use this video as a reference tool. Thank you very much for watching.